Lesson 4. The 30-60-90 triangle. In geometry, you learn that when you bisect an equilateral triangle vertically, the result is a pair of identical right triangles. Each triangle has a right angle, a 60-degree angle, and a 30-degree angle, and is called a 30-60-90 triangle. Starting with an equilateral triangle that has a side of length 2, gives you a triangle with a hypotenuse of 2 and a short leg of 1. You can use the Pythagorean Theorem to calculate the length of the longer leg. Here we fill in 1 for A and 2 for C, and solve for B. So the longer leg of the 30-60-90 triangle has a length of radical 3. You can use this triangle to find the values of trig ratios when theta equals 60 degrees. For example, the sine of 60 degrees equals O over h, which equals radical 3 over 2. The cosine of 60 degrees equals A over h, which equals 1/2. And the tangent of 60 degrees equals O over A, which equals radical 3 over 1, and simplifies to radical 3. You can also use this same triangle to find the values of trig ratios when theta equals 30 degrees. For example, the sine of 30 degrees equals O over h, which equals 1/2. The cosine of 30 degrees equals A over h, which equals radical 3 over 2. And the tangent of 30 degrees equals O over A, which equals 1 over radical 3. As with other values that contain a radical in the denominator, this value can be rationalized by multiplying both the numerator and the denominator by radical 3. This results in the value radical 3 over 3. And this is the value that we will use for the tangent of 30 degrees throughout this course. As with the trig ratios for 45 degrees, the trig ratios for 30 degrees and 60 degrees are also used frequently in trigonometry. To begin memorizing them, it is helpful to note that both the sine of 30 degrees and the cosine of 60 degrees both equal 1/2. And that all of the other ratios include the value radical 3.